So far we've looked at velocity time graphs where the acceleration is constant. So what that means is that the graph is always a straight line graph. So for example, in the first 3 seconds of motion of this particle, it goes from 0 meters per second velocity to 6 meters per second velocity. So this means it's got a constant acceleration, because it's a straight line, of 2 meters per second squared. For every second, it increases velocity by 2 meters per second. So what we're going to do in this chapter is we're going to think about what happens when the acceleration is not constant. So for example, on this graph, this velocity time graph, because the gradient represents acceleration, if I just look at what's happening to the gradient's increasing. So that means as time goes forward, the acceleration of the object is increasing. And similarly, the acceleration of this object is decreasing. So let's have a look at an example. In this example, we're given an equation which tells us the displacement of an object from the origin at a given time t. So it might be useful to think about what this graph looks like. So I've just graphed this equation here, and you can see that displacement, obviously we start at the origin. When t equals 0, the displacement is 0, and then the displacement goes negative, and then it starts to become positive again. So if we think about what's happening in a straight line, if this is our particle and that's the origin, then this part of the curve, the displacement time curve, means that if we take this as our positive direction to the right, it means that in the first few seconds, or in the first 0.7 seconds, it's moving away in the negative direction. And then it stops moving more negative and starts moving towards 0. So it moves around like that. And then it moves in a positive direction. It gets further away in the positive direction. So in part A, we're asked to find s when t equals 2. So this is just substitution. So all we're going to do is substitute in t equals 2 into this equation. So 2 times 2 cubed minus 3 times 2. And we can work out what that is. And we find that that's equal to 10. So the displacement is 10 from the origin, and it's plus 10, which means it's actually to the right of the origin if that's our positive direction. So we're somewhere up here on the displacement time curve. Let's have a look at B then. So it says the time taken for the particle to return to O. So if we've returned to O, it means that the displacement is 0, because if we're at O, we've not moved left or right. So we can say at O, we know that s equals 0. So let's solve that. So 0 equals 2 t cubed minus 3t. So let's take out t as a factor. So we're going to have 2t squared minus 3 inside the bracket. So we're going to get two solutions, either t equals 0, or we're going to have 2t squared minus 3 equals 0. So if we solve that, we'll get t squared equals 3 over 2. And let's take the square root of that. So t is the square root of 3 over 2. And if we work that out, we get 1.22 seconds to 3 significant figures.